Good morning, ladies and gentlemen. I am very pleased to give a small contribution by video message to the interesting and tight agenda of this workshop. The European Union Agency for Railways sets the technical and safety standards that harmonize the rail system in Europe. And we have recently been invested with new powers. Starting from 2019, we will deliver the authorizations for rail vehicles in Europe and the safety certificates required for railway companies to operate. One of our responsibilities is the harmonized train communication and control system, the European Rail Traffic Management System, ERTMS. ERTMS contributes to the single European rail area by ensuring interoperability throughout the rail system across national borders. Today, more than 23,000 kilometers of lines and almost 7,000 vehicles are equipped with ETCS in the European Union, in addition to 90,000 kilometers of lines covered by GSM-R. As system authority for ERTMS, we write and update the specifications in cooperation with the sector, and we will authorize the placing on the market of rail vehicles fitted with ERTMS. And we will also give the green light to national authorities for placing in service ERTMS lines. ERTMS is a reality. The challenge now is to increase the business case for faster migration and to enable cost-effective implementation also outside the core rail network. The agency has identified a number of game changers, meaning compatible add-ons to improve functionality and to reduce cost. Satellite-based positioning is one of these game changers. ERTMS controls in real time the speed and location of the train in order to ensure it respects the allowed dynamic envelope. Speed information is derived today from traditional wheel rotation counters and from radar sensors, while location is defined as linear displacement to beacons positioned on the railroad. Wheel sensors are prone to errors from slip-slide. Radars can be affected by environmental conditions. However, satellite positioning can represent a more cost-effective odometric solution because sensors on wheel boxes are costly to maintain, cabling is exposed to harsh situations, and the same is true for radars under the car body. Satellite positioning in absolute coordinates can enable savings on the number of beacons to be installed on the trackside. To deliver those benefits, the technology must overcome two main burdens. First, to achieve the precision, integrity and availability needed for precisely discriminating between parallel tracks, coping with urban canyon and other obstructions, and secondly, to demonstrate equivalence in terms of the high safety requirements inherent in the rail system. For the first time, the signaling community has accepted the challenge to integrate in a compatible manner the satellite technology in the ERTMS roadmap. Now, it is up to the satellite community to take up the challenge and to demonstrate concretely how satellite technology can deliver in terms of railway needs. RHINOS demonstrates promising advances, and we will follow with interest the future steps. We need all together to cross the boundary between two very different sectors. We use different languages in our domains, and we use different set of parameters and units of measure. Rail has a specific culture and a specific safety philosophy. It is our intention as the European Union Agency for Railways to drive modernization, safeguarding the outstanding safety levels of the system, but enabling rail also to increase its attractiveness, to ensure the modal shift that transfers passengers from unsafe roads to the safer, greener mode of transportation. I wish you a successful workshop with fruitful discussions. I look forward to hearing further progress from the project in this important field.